All right, let's dive in. We're going to talk about one of the greatest stories ever told, and that's the story of physics. Really, it's a story about human curiosity. This deep, relentless drive we have to understand absolutely everything, from the tiniest little particles to the biggest galaxies you can imagine. So just think about it for a second. How did we get here? How do we go from looking at a thunderstorm and thinking, wow, the gods must be angry, to predicting the weather, building the phone in your pocket, and literally landing robotic explorers on another planet? Well, that incredible leap, that right there, is the story of physics. So let's start at the very beginning. Our story really kicks off with the first huge revolution in the way humans thought. And it wasn't about discovering a new star or finding a new element. Nope, it was about discovering a whole new way of thinking. This slide really nails that first massive shift. For most of history, the world seemed like a chaotic playground for gods and spirits. Things just happened. But then some early thinkers came along with this totally radical idea. What if the universe isn't random? What if it's all a really complex machine that follows a set of consistent, unchanging rules? This move away from myth was the first essential step. It was the belief that we could actually figure things out just by using our own minds. But just thinking about things can only get you so far. The next giant leap forward meant we had to do more than just ponder the world. We had to start having a direct conversation with it. And this is where guys like Galileo Galilei come onto the scene. He really championed this revolutionary new tool, the targeted experiment. See, instead of just watching nature do its thing, Galileo figured out you could set up these controlled, repeatable little scenes to poke and prod at one specific question, like, how does a ball fall? This was a complete game changer. And that led to this, the core loop, the very engine that drives physics forward. It's a simple but incredibly powerful cycle. First, you simplify a messy, real-world problem into a basic model. Then, you test that model with an experiment. And finally, you take what you learned and use it to make your model even better. It's this back and forth, this constant dialogue between our ideas and what nature actually does that makes all the progress possible. So, what do we mean by a model? The idea of a mass point is the perfect example. If you want to figure out how a planet zips around the sun, you don't need to get bogged down with its mountains or its oceans or its clouds. You can simplify it, treat the whole thing as if all its mass is squeezed into one single point. And that's the magic of a good model. By ignoring the messy details, you can uncover the deep, fundamental rules, like gravity, that are running the whole show. Now, this new method was so incredibly successful that for a couple of centuries, it really seemed like we were on the verge of knowing everything. It felt like we were finally reading the blueprints to a perfect, predictable, clockwork universe. And things moved fast. You had Galileo laying down the method. Then Isaac Newton came along and basically wrote the instruction manual for the cosmos with his laws of motion and gravity. A century and a half later, James Clerk Maxwell rolled electricity, magnetism, and light into one stunningly beautiful theory. It all just fit. Everything was clicking into place. The confidence was just off the charts. This idea, sometimes called Laplace's demon, really sums up the whole attitude. It's this belief that the universe is just one giant deterministic machine. The thinking was, if you could just know the exact position and motion of every single particle at one instant, you could, in theory, calculate the entire past and future of everything. No problem. But you know how these stories go. Just when it looked like we had it all figured out, some really weird, unexpected things started to pop up in the lab. And that beautiful, perfect clockwork universe, well, it was about to get some pretty serious cracks in its foundation. I mean, the feeling at the time was that the job was basically done. A lot of very smart physicists genuinely thought they were just tidying up a few loose ends, that the great book of physics was about to be closed for good. But those loose ends, those last few nagging little problems, yeah, they turned out to be anything but minor. They were little whispers from the universe that our understanding wasn't just a little bit off, it was fundamentally wrong. And here they are, the big ones. First, get this. Experiments showed that the speed of light is always the same, no matter how fast you're moving towards it or away from it. That just completely broke Newton's rules. Second, our best theories were totally useless at explaining the colors of light that hot objects glow with. And third, no one had a clue why atoms only spit out and soak up very specific colors of light, like some kind of cosmic barcode. These weren't just puzzles. They were deep, screaming contradictions that would force a total reboot of physics. And that revolution is what brings us to today. We didn't end up finding one final answer.
What we found instead was that the map of reality was way bigger, much stranger, and honestly more beautiful than anyone had ever dreamed. And it's a map we are still drawing.
You see, solving those nagging problems gave birth to the two pillars of all modern physics: Einstein's theories of relativity and the bizarre, wonderful world of quantum mechanics. They showed us a universe where time can slow down and space can bend, where particles can literally be in two places at once. The simple clockwork idea was gone, replaced by something far more mind-bending and amazing. And what's wild is that we also learned that even with the old simple rules, perfect prediction isn't always in the cards. This new field called chaos theory showed us that for really complex things like the weather, the tiniest, most insignificant change at the start can lead to a massively different result later on. That's why, even though we know all the physics, we still can't tell you for sure if it's going to rain 2 weeks from now. So you see, this forced a huge shift in what physics is even about. That old dream of finding a single final theory of everything has kind of been replaced by something more humble and, I think, a lot more exciting. We now see physics as this ongoing process of building a better and better map of reality, a map that gets more detailed and more accurate with every new discovery. We've basically traded the idea of a final destination for the thrill of a never-ending journey. And this really captures the spirit of it all perfectly. The map we have so far is incredible. It lets us do amazing things. But every physicist out there knows the map is still incomplete. There are these huge, mysterious blank spots labeled dark matter and dark energy. We still have deep questions about the nature of reality itself. The great age of discovery? Oh, it is far from over. Thanks for joining me on this one.